And now for periodic table notes part 2. So with the periodic table, we have a lot of different groups and periods. And what we're going to do today is chunk the periodic table into different pieces. And so you'll notice that it's organized in different colors. Like here's orange, and then we got lighter orange, and then we got yellow. We got some pink down here, purple, blue, etc. So each of these corresponds to certain shared characteristics between multiple elements. What I'm going to do now is detail like why they're organized this way. So the first thing that you'll notice is that if we go back to our part 1, when it came to the vertical groups, the columns, I only had you label the first 2, where they were 1 and 2. And then I only had you label the next 6. So that would be 3, 4, 5, 6, 7, and 8. Now, those 8 groups, the tall ones, okay, you'll notice I call them tall because they're taller than everybody else. All right, the first 2 and the last 6 are called the representative elements. All right, represent. So the thing about these is that we're going to pull for valence electrons only from the representative groups. The reason for that is that these elements in the middle, which I'll name in a bit, those have a variety of different numbers of valence electrons. So we don't need to really worry about them. If I do use valence electrons for those elements, I'll have to give that information to you. But again, if I'm in group 1, I have 1 valence electron. If I'm in group 2, I'm going to have 2 valence electrons, and so on. Okay, so it's the first 2 groups and the last 6. So then, what about the guys sandwiched in between those? So those are all elements between the representative elements. So, whoops, line. So if I go back, okay, the transition metals are right here. It's this yellow brick right here, okay? Now that also includes the lanthanides and the actinides because they're sandwiched in there as well. But for most purposes, the lanthanides and the actinides will be referred to by their actual names, okay? So I'll call these by name. But the transition metals are specifically these guys sandwiched in between. So the metals have a few characteristics. They are ductile, which means that they're able to be made into a wire. A way you can remember this is if you've ever had braces. I had them once upon a time. It kind of makes you feel like a duck because it makes your lips bow out a little bit. I mean, I'm not calling anybody out by physical appearance, but it does make a little bit of a difference. And so you could, for lack of a better example, you could think that braces kind of make you feel like a duck sometimes because the wire, okay, kind of makes your lips bow out a little bit. Malleable would be anything that can be made into a sheet, so like tinfoil, or if you came to school in a car today, okay, your car is made out of sheet metal. So any metal that was made into that was considered malleable. And then we have 3 elements in here that can produce a magnetic field, so iron, cobalt, and nickel. Okay, now the next group would be the alkali metals. Now, here's a tip. So our first 2 groups, okay, so these next 2 groups I'm going to call by name are these guys. They have similar names, so I'm going to give you a tip on how to differentiate between alkali metals and alkaline earth metals. Okay, spoiler alert, alkali metals are all the guys in group 1 except hydrogen, because hydrogen is not metal, okay? So it's all these guys in group 1, and then the alkaline earth metals are everybody in group 2. Alkaline earth has one more word than alkali does before you get to metals, okay? Alkali metals versus alkaline earth. That's 1 word versus 2 words without the metal part. Well, alkali having 1 word before metal is going to be group 1 because it has 1 word before metal. Alkaline earth metals is going to be group 2 because it has 2 words before metals. Okay, so that's a helpful way to memorize that. These guys are towards the left of the periodic table, and so that means that they're very, very reactive. Okay, that's characteristic of both groups. Okay, so when we go down here, and why are they reactive? We'll talk about that later. But the metalloids, okay, are these light blue guys. And so these light blue guys are going to be a little bit more difficult to memorize, and so let me show you how to do that. If we go down to this blank periodic table, I have made you a black staircase, okay, that you guys are going to make on your own periodic tables that I'm giving you out today. So the thing about that is the way you do this is you find boron on the periodic table, and you go to the left of it, and you make a black line, and then you make a horizontal line, okay? So then you just keep going on the right of aluminum, and you just keep making that staircase. So it's just a straightforward staircase, down one, over one, until you get to the right side of polonium. Now, how do you do the metalloids? With the exception of boron, which is the only one on top of this staircase, you step down. Let's pretend that I have a boot here. You step down to the next stair, okay? Now, when you step on that next stair, all other stairs except for boron have the top element above it considered a metalloid, as well as the element below the step. And every step, okay, so then you step down, right? Step down to the next step. The one on top, the one on bottom. Step down to the next step. The one on top, the one on bottom. When you have 7 metalloids, you're done, okay? So that's how you memorize the 7 metalloids. And if you're having trouble with that, I can sit down with you at some point and go along with that. But we'll draw that in your own periodic table so you never forget it. So the next step, the metalloids they have characteristics that are kind of between metals and nonmetals. So they're semiconductors. They can conduct heat or electricity, but not as well as a full-on metal can. So the next thing is that we have the nonmetals, okay? And these are all the elements that make up you. Now, you do have small traces of metal in you, but we'll get to that later. So the nonmetals are pretty easy. Once you get the metalloids, actually, if you can remember this, Chnops, CHNOPS, and then SE, those are all the elements that make you. They're all sandwiched over here between the metalloids, between the metalloids and what's called the halogens. So we're going to have those guys. So they're in purple right here. So C, okay, there's the carbon. Chnops, the next one would be hydrogen. And then the rest of these guys are all sandwiched together. Okay, so the right bit's here on the right side of the metalloids. The only thing that people do is they forget about hydrogen. Don't forget about hydrogen. It is not a metal. Okay, it is a flammable gas. So if we go to the halogens, which are our next group, is that, oh, by the way, nonmetals are not very good conductors of electricity or heat, and they do not reflect light. The thing about the halogens is they're everybody in group 7, okay, right there. So you just find fluorine, which is the 7th group, and then you just go down. That's all the halogens, okay? And halogen means that they form salts. So they exist in 3 states of matter: solid, liquid, or gas. And I'm going to point out something. So if you notice on this periodic table, you'll have many symbols, most of them written in black, okay? There's an occasional symbol that is written in blue, and there's a group of symbols that are written in white. If you go right here, that means the state of matter. If they're written in black, it's a solid element at room temperature. If it's in blue, it's a liquid at room temperature. And if it's white, it is a gas at room temperature. So that's why they're written in different colors. So then, the last group that we have to deal with are the noble gases. These guys have a full valence shell. So helium, which only has, there's the box that represents the nucleus of helium, has 1 subshell. Remember from part 1, you can only get 2 electrons in that first subshell. So since it has 2 electrons to be neutral, and it has 1 shell, it is considered a full outer shell for that atom. But when we get down to neon, which has 2 shells because it's in period 2, neon has 10 protons, okay, so I'm going to want 10 electrons to balance it out. So to get those 10 electrons, I can put 8 in the outer shell, and that's going to be true for the rest of these guys going down. They can get 8 in their full shell, in their outside shell. So that means that that shell is full. It can't get any more than 8, and so that's why they're in this group. Now, the way you react in chemistry is because you are missing an electron or more on your outer shell. And so then you bond with another element to fill it up. Well, these guys don't need any electrons, so they do not react, okay? So noble gases do not react. Now, helium, I already talked about, and so these guys are just, literally, it's just group 8 going down. That's what you got to do, okay? And that's that. So that's all we're going to worry about today. So for today, you're just going to answer the questions that are on page 3 and of your notes, and then you're going to make sure you have part 1 completed. If you have any questions, please email me or come see me in class or during SLT.